Okay, so I'm gonna go through this thing and, okay, if here's a record, just go ahead and, just say the numbers.
Okay.
Now, okay, what I'm gonna do is, when I say 1 pound, you'll probably get it, as close to that. Now, what I'm saying, see, I gotta play with this thing here just a little bit. And, that's gonna make a little bit of difference over there, I believe.
So we're doing load and RPM?
Yeah, well, okay, see what this thing here is, it measures pounds. Now, how come when you do graph like on the DC motors, everything was the torque was equal to pounds, is the fact that this arm right here is 1 foot from here to here. It's actually not 1 foot, but somehow the way it makes angles is supposed to be equivalent to 1 foot. So then the pound scale times 1 is the torque. Bear with me on that.
Yeah.
Okay. Huh?
Oh, you started recording?
Yeah.
Okay.
It's not on.
Hey, now this is the mine, you wonder how you understand what I'm doing here. A young man like you in the top white bag up.
Maybe you should stop it and then start it again. Cause I'm pretty sure that's taking up some space.
It's 0.5.
It's-
0.5.
We
It's
got
not
all
getting you-
zeros
yeah.
up here.
It's not reading.
Okay. What is? Now what's the matter?
There we go.
Okay. Here's the first reading, 0.5.
1784.
Okay, 1,
1780.
2,
1776.
3,
1771.
4,
1758.
5,
1756.
6,
1752.
7,
1747.
8,
1735.
9,
1726.
17,
1717. $16.99.
Twelve,
$16.91.
thirteen,
$16.75.
fourteen,
$16.57.
fifteen,
$16.32.
sixteen,
$16.07.
that's probably all. Do I need the stool down? Here you go. Don't make me uncomfortable.
Make mustard.
Okay, now. Okay, in class, we talked about
I ain't got a swing.
a couple of terms. It looks like I no load. Now, that's gonna be the current that this meter's reading with no load on it. Okay, if I take a look at the name tag here, okay, what's going to say here that the full load speed is 1720 and the full load amps was 9.5. We went well above it. The weighted full load speed of this motor is 1720. We overloaded. Now, a couple things to look at. If you don't look at this thing here, okay, right here is going to be when I start the motor. What's things? I don't know if I set this thing up or not. I'm getting electrocuted. Y'all like that, wouldn't you? Okay. Now, we start the motor. We talked about the block motor current of how it was 6 times normal full load current. Okay, look at it when I first started. If they take down the balance, and I'll come back. Right now will be the no load current. Okay, the full load current will be like that current right there. That's the number that we talked about in class.
Which one of these numbers do you look at?
Oh, it's on the 20 scale. That's with the top scale times 2.
Okay.
It's still right there. It works right there on the 20, I believe, isn't it?
Okay.
Now, one other thing. Let me take a look at too. Start the motor. Oh, it's on the 4. Remember what this thing here's about? What's this thing we illustrate for? Altered phase, okay? Okay, look at the meter there. It's now being 0. It's got that little thing there, but it's just passing it right now. Where the other conductor, I'll back out anyway. Head into classroom and talk about any questions, comments.
What happens if you load it now?
If you blow it out, it only go up to a small amount. It won't go all the way. See the difference? If I got the phase in, difference. Phase sequence determinants is, when I hook this thing up here, like I'm gonna put this like the light bulb, like in phase A, the middle bulb like in phase C, and L3 in the phase C. Okay, all's happening here now, if I want to change direction or rotation of that motor, I could come in and change any two of these three leads. But there were two that we decided to change. So I'm gonna cut the power on, start the motor, excuse me. Okay, well actually, okay, as far as the phase sequence right now, the phase sequence is going to be L1, L2, and L3, or A, B, and C, however we look at it. Now this phase sequence will cause the motor to run, okay, looking over the motor at the load, it's going to be running clockwise. Okay, does that ask for the RPM? I don't think it does.
The first one did not, the second one.
Okay, then I'll start the motor. It's running this way with this phase sequence. Okay, so if I want to change the phase sequence, better make sure I cut that off. Y'all might see me dance here, whether it gets shocked here or wood here. Now, I can change any two of these three leads to change the phase sequence. Which one are you going to change?
A and B.
A and B. Okay, so I'm going to take A loose here. We'll take B loose and put B up where A was. And A down here. Now, when I cut the power on, okay, what did we notice? Okay. Now the phase sequence now is going to be BAC. Okay, now I'm going to start the motor. Let's see what happens now. Any questions about today's lab?
And it said to connect it, shown in figure 2, which is buffer lump.
Yeah, that's what this thing here is.
Oh. How did you do that? The JCB don't even know
Keep his hammer turned that way, fella.
Put that on YouTube.
Just the dancing part.
Okay. We go back in the room now. Here is times 10. Got the multiplier which is in the plant. And you divide it by 10 to get the current there. And okay, your watts, okay, it's either watts per phase, or at the far right-hand column will be the total watts of each phase. The end will be the RPM. And I believe I should take care of everything.
I have a question. You said total watts per phase? Because I know there's 3 different phases.
Yeah, 3 phases. You have like an A, B, C, and then out here you have the total. Like, let's say this would have been 2, 2, 2, then this would have shown 6 out here.
Okay, then. So the total.
This would be, okay, each one of these would be the watts for that particular phase. And this would be the total, adding all those 3 up for you.
So you want totals for everything?
Yeah, probably be the best. However you think works out, will work out the best for you.